Alright, learners, this theorem is very important, and if you check the past question paper, whether it is grade 11 or grade 12, you can see that they ask this theorem frequently. Okay, so this one and the tan code theorem, a very important one. Okay, just please keep more attention in those theorems. Okay, so what is this theorem saying? The angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc on the circle. In short, we say angle at center is equal to 2 times angle at circle. That's how you have to write as a reason. Okay, so let me point a arc here, an arc here, that is arc starting from A, B. So arc AB, I'm talking about the minor arc from A to B. Okay, arc AB on a circle subtending an angle at the center. So from A and B, center is O. So this is the angle made by the arc AB. Arc AB means this one. Okay, this arc AB subtended at the center. Angle made by those points A and B, where at the center, okay, is double the angle at the circle. The very same point A and B on C. There's a point here. Let me plot a point C here. So very same point A and B, this time subtending on a circle. Did you see that one like this? Like this. Okay, see this one. And whatever is C times 2 is going to be O. For example, if this one is 10 means it's going to be 20. That's how it is. Is it clear? So angle at the center is bigger than angle at the circle. How much bigger? Double. You understand? So that's how you have to see this. So how do you prove that? If this one is x, then this is going to be 2x. Is it clear now? So that's how you have to prove. Okay, it's a very important one. Here a construction is needed. Guys, did you see radii here? OA is a radii, OB is a radius, not radii. Those OA and OB, they are radii because plural is a radii. Okay, and let me construct another radius OC. See, like this. OC is also a radii. As a radius, and now we can say OC, OA and OB all are same. And let me extend OC a bit to down. Okay, so okay, and let me write it here. So that line is going to divide the angle O into two parts, O1 and O2. Clear? So what we want to prove here the given part is the circle with the center O, the arc AB subtending the angle at center and the ACB at the circle, isn't it? Is it clear? Okay, so the given part, let me write it here. Given part is arc AB. First thing is circle with the center O. Center O, isn't it? Then what else are given here? O, angle AOB. AOB, that is the arc subtending angle at the center, then angle ACB. Also given, isn't it? And you have to prove what? Prove AOB, angle AOB is equal to 2 times angle ACB. This one you have to prove. Clear? So here you have to construct OC. Construct OC, isn't it? Construct OC and produce the line to K. And extend OC. Extend the line OC to K, isn't it? A little bit down, so that the angle we can see O1 and O2. O1 and O2. Is it clear? Guys, look at now this triangle AOC, this one, and AOC, that I'm talking about, this one, AOC, this one. Isn't it this one isosceles triangle? Because OC and OA, they are same, isn't it? And this line OC is dividing angle C, C1 and C2. And you agree that C1 and A, they are same because they are the angles opposite equal sides, isn't it? So in triangle, which triangle? AOC. Look at that triangle AOC. C1 is equal to angle A. What is the reason? Angles opposite equal sides. That is isosceles triangle, isn't it? So this O1, angle O1, O1 is the exterior angle of the triangle. Do you agree that? See, exterior angle, isn't it? O1. You know that O1 is equal to what? C1 plus A. Exterior angle, isn't it? Exterior angle of a triangle. So these two results, you know that. Okay, first one is isosceles, second one is exterior angle. Now instead of A, I can put what? Instead of A, I can write C1 because they are same. That is O1 is equal to C1 plus again C1. That is O1 is equal to 2C1. Do you agree that? Okay. Similarly, O2, we can also write O2 is what? Because this is C2 and B, isn't it? So, and B and C, this also isosceles triangle. C2, angles C2 and B, they are same. So, in the very same way, I got O1 is equal to 2C1, O2 is equal to 2C2. Do you agree that? Okay. Then what will happen if I add O1 and O2? O1 plus O2, isn't it equal to AOB? AOB, that is the full angle, isn't it? This one, AOB, which is equal to what happened because I add this one and this one, O1 and O2. So I have to add, which is equal to 2C1 plus 2C2, isn't it? Okay, which is going to be what? 2 is common, take it out, C1 plus C2. That is the full C. C1 and C2 is full C. That or same as ACB. So we can write AOB, that is the angle at the center, 2 times what is C1 plus C2 is ACB. So we are done. So very important results, angle at the center, 2 times angle at the circle. So this is how we prove this. Okay, so very important one. Please try to study. Now let's do a few examples, and we can be done with this theorem. Okay, just do some examples. All right, guys, let's do this question quickly. Find x. Did you see that theorem there? Okay, BC, angle at the center, that is, we can see that 124. And what is the value of x? That is angle at the center, that is BOC is equal to 2 times, if I name this one is BAC, isn't it? BOC is 124 is equal to 2 times x. So we can find the value of x. How do you find the value of x? So because 120, half of 124 is going to be x. That is, x is equal to 124 divided by 2. What is that? It is going to be 62. 62 degree. Is it clear? So here the result is angle at the center is equal to 2 times angle at a circle. So each time when you apply this result, you have to write that. Now go to the next one. How do you find the value of x? This x is, when you multiply, is going to, here is going to be what? 2x, isn't it? 2x. So can you find the value of x? So you have to first to find what? O1. That is, you know that 244 is this one. Okay. Then what is left? Because the full circle is 360. That is the angle around a point. Angle around a point. So we can find O1 first. What is O1? O1 is equal to 360 minus 244. What is that? 360 minus 244 is 116, isn't it? Let me check. 244 is equal to, yes, 116. 116. That is O1. Isn't it? So what is the value of x? X is going to be half of this one, 116, isn't it? This 2x is going to be 116. So 116 divided by 2, because whatever is at the center divided by 2 is going to be x. So it's going to be what? It's going to be 58, right? Divided by 2, which is going to be 58. 58 degree. Now, how do you find the value of y? Y is half of 244. What is half of 244? Which is going to be 122. 122, isn't it? So we can do that question like that. Okay, so here the reason that you are going to write angle around a point. That is here. Like that. Then x, how do you get it? Angle at the center. Angle at center 2 times angle at circle. So whenever you write a geometric ideas, you have to mention the reason also wherever you write it. Angle at the center 2 times angle at the circle, or some of the angles on a straight line, or angles some of the angles in a triangle, like that. The reasons you have to write it. Now we move to question number 3. Find the value of x. How do you find the value of x? Because O is the center, isn't it? Oh, I didn't write O here. This is O is the center of the circle. So you have to find the value of x. So learners, don't divide 110 by 2. That is wrong. This x is related to what? This angle. Do you understand? Angle at the center. So what is that angle? 360 minus 110. 360 minus 110, which is going to be 250. If I name this one O1. So O1 is equal to 360 minus 110, which is going to be 250. That is O1. So here the reason is angle around a point. Angle around a point is 360 always. Is it clear? So I got a 250 here. You understand? Now we can find the value of x. How do you get the value of x? X is half of 250. That is 250 divided by 2. Okay, at the center is always double at the circle. Okay, so 250 divided by 2, which is going to be what? 125. 125 is the answer. So this is how we do this question. Okay, so this knowledge, how did you get? Angle at center is equal to 2 times angle at circle. So it's a very important knowledge, guys. Don't forget that. Okay, guys, because of this theorem, we can get a very important result. We can look at this circle. If an arc AB subtending an angle at the center, see, like this. Okay, so O, okay, for O is the center. Then if O is 2x, then this angle C is going to be what? Half of that, that is x, right? Okay, the very same arc AB is subtending another angle, the very same segment, that is the major segment. So this is also going to be x. For example, if I call it D, D is also x. So now look at here. Here also it is subtending very same arc, this also going to be x, isn't it? So angles in the same segments are same. That's what we say. Angles in the same segment. Actually, this result we got it because of this theorem. Okay, see, very same segment, that is the or angle subtended by the same chord AB. It's also correct. All angles are same. Angles subtended by the same chord are same. Okay, so on the circle, I'm talking about at the circle A, C, D, E, I'm talking about, not at the center, at the circle. All angles are same. We need this result in finding lot of values. You have to use this one in different questions. Okay, so angles subtended by the same chord or angles in same segment. Here the reason normally we write angles in same segment. Okay, that's the result. We don't need to prove this one, but the result is very important. Angles in same segment. Okay, all right. So let me stop it here.